Now, what happens if you're trying to solve a quadratic equation, but not to the x-intercept, but instead to another equation? So, for instance, you're trying to find where your quadratic overlaps with, say, a linear equation. Well, this would be simultaneous equations, where you're looking for the valid set of coordinates that's valid for both equations. So let's say we have these two equations. We have this quadratic and we have this linear, and we're trying to find where we have those two valid sets of coordinates, where they're overlapping. Now, when you're working with simultaneous equations, there are two methods that you can use to solve it. We have the elimination method and we have the substitution method. So let's use the substitution method first to solve this. Now, with the substitution method, you're substituting one thing in for another. So we can see that this is already written out in such a way that we have y is equal to and y is equal to. So this could substitute in as the y in the other equation. And we could have x plus 6 is equal to x squared plus 2x minus 6. And then we use algebra to solve for x in this case. And then once we have x, we sub it back into one of the starting equations and we solve for y. Now, because we have two valid solutions, when we solve for x, we're going to get two valid solutions. So simplifying this, we can move it all over to one side of the equation. So we have 0 is equal to x squared. Now you have 2x minus x, so you're going to have 1x remaining. So you're collecting your like terms as you're moving it over. And you have minus 6 on both sides, so this becomes minus 12. So minus 6 minus another 6 gives you minus 12. You can see that this is now in the form of a quadratic equation where y is equal to 0, well, where one side of the equation is equal to 0. And you can now use your quadratic equation, x is equal to negative b plus minus square root b squared minus 4ac all over 2a. So x is equal to negative b, so negative 1, plus minus square root of 1 squared minus 4ac all over 2a. Simplifying this, we have x is equal to minus 1 plus minus square root 1 minus, so minus minus, that's actually a positive. 4 times 1 times 12, that's 48. 2, so x is equal to minus 1 plus minus, that simplifies to 49, square root of 49 is 7. Over 2. And so our x solutions are going to be 6 on 2, which is 3, and minus 8 on 2, so minus 4. So we plug it in up here, x is equal to 3, x is equal to minus 4. And then what you're doing is you're taking one of your starting equations, let's say y is equal to x plus 6. So you normally pick the simplest equation, y is equal to x plus 6. And we're subbing in our two x values. So y of 3 is equal to 3 plus 6, which is equal to 9. So at x equal to 3, the y value is 9. We have that set of coordinates being 3, 9. And you plug in your other x value, which was negative 4. Minus 4 plus 6 is equal to positive 2. And so this one here would have been minus 4, positive 2. Now, this doesn't look like it's a positive 2, but this was just a random drawing that I did at the start. So if we were to plot our two equations in Desmos, let's see if these are the correct solutions. Now I've plotted these two equations in Desmos, and we see the point of overlap is minus 4, positive 2, and 3, 9. So these were the correct solutions that we found. And then the other method we could have used to solve this is the elimination method. With the elimination method, you are scaling your equations such that when you add one equation to the other or subtract one equation from the other, you're eliminating one of your variables. So you're eliminating either the x or you're eliminating the y's. And so if we label this as equation one, and we label this as equation two, our elimination method could be, well, we see the y's already have the same coefficient out the front of them. So we could just go, say, for instance, equation one minus equation two. So y minus, and what you're doing is you're minusing the left-hand sides and then the right-hand sides. So y minus y on that left-hand side and x squared plus 2x minus 6 minus, so you may as well put these in brackets because you don't want to only associate that minus with the first thing. You want to associate that minus with every component from that second equation. It's minus x plus 6. And another thing to note with the elimination method, if you're doing 1 minus 2, so for instance, one equation minus another equation, you always want to keep that order for the same thing. So in this one here, that would have been y1, y2. So y1, y2. We are always sticking to that order of 1 minus 2 for both sides of that equal sign. Now y minus y is 0. So you have x squared. Then you have 2x minus x. So you have a positive x remaining. You have minus 6 minus 6, so minus 12. We have x squared plus x minus 12. And you notice that this actually got us to the same line as what we did through the substitution method. 0 is equal to x squared plus x minus 12. So I won't follow this one on because it'll be the exact same steps as what we did for the substitution method after this point. Now, normally, again, you would pick either the substitution method or the elimination method that makes your job easier for the set of equations that you're trying to solve. Okay, we've got another one of those questions here where we have a quadratic equation and a linear equation, and we want to find the points of overlap. So have a go at solving for the x and y for these two equations, please. Okay, hopefully you've had a go at this. Now we can see that the y's have the same coefficient out the front of them. So we could either apply the elimination method or the substitution method, and they should both be relatively as easy or as hard as each other. So it doesn't matter which one you really chose for this question, and I might choose a different one to what you did, but we should get the same answer. So I think I'm just going to go with the substitution method for this one. So we have x plus 2 is equal to 2x squared plus x minus 6. And then we're moving this chunk of stuff over to the other side to get it into the form where we can apply the quadratic formula. 2x squared, x minus x. So we have 0x, and then we have negative 6 minus 2, so minus 8. Now, we like to keep things as simple as possible. So we have a 2 and an 8. We can factorize out 2 and move it to the other side if we want. So this could be 2x squared minus 4 equal to 0. And then when you divide both sides by 2, that 2 just disappears. 0 is equal to x squared minus 4. And then we move the 4 over to the other side. So 4 is equal to x squared. Square rooting both sides. X is equal to plus minus 2. Now, don't forget that plus and minus, because if you had positive 2 squared, well, that would give you positive 4. Or if you had negative 2 squared, that would also give you positive 4. So we have to include that plus minus, and that's how we get our two solutions for this one. So plugging that into one of the equations, and we can just plug it into any, we'll get the same answer. So we have x plus 2. So we'll plug this x in. So y of positive 2 will give us 2 plus 2, which is 4. and y of -2 will give us -2 plus 2, which is 0. So our two sets of coordinates, so for +2, we had a y value of 4, and for -2, we had a y value of 0. So, sorry. So just recapping what I did, I didn't realize I was going off the page there. So we plugged in a +2. We had +2 plus 2 gives us +4. And so our set of coordinates there is +2 and 4. And then we had a -2 plugged into that equation. So we had -2 plus 2 gives us 0. So our second set of coordinates was -2 and 0. Now jumping on over to Desmos to see what that graph actually looks like. We've got both plotted out there, and we can see that one set of intercepts are -2 and 0, and the other one is +2 and +4. Okay, I've got another set of equations, so one quadratic, one linear. Have a go at finding the points of intercept of these two equations, please. So when I look at these equations, the first thing I notice is this one is a fraction. So what I'm going to do is I'm going to make my life simpler by making it so that it's all on one line and there is no denominator. So I'm going to times this whole equation by 2 on both the left-hand side and the right-hand side. And so this equation, so if I label this one as equation 1 and I label this one as equation 2, restructuring this one, I'm going to get 3y is equal to 4x plus 4. So times 2 on both sides. And I'm going to label this one as equation 3 because this is going to be the one that I'm going to use. Now, I see that I've got 3y and 3y, so they have the same coefficient out the front of each y. So again, I can either use the elimination method or the substitution method, and my y's will disappear. So because last time I used the substitution method, this time I'm going to use the elimination method. So I'm going to go equation 3 minus equation 1. I've got 3y minus 3y is equal to 4x plus 4 minus x squared plus 4x minus 11. So simplifying this, my 3y's cancel out. I've got 0 is equal to 4x minus 4x. So my 4x's actually cancel out as well. Then I've got a negative x squared, and 4 minus 11 gives minus 11 gives me positive 15. So I can move this x squared over to the other side, and I can avoid using the quadratic formula because it's unnecessary in this particular question. Moving that over, I have a positive x squared is equal to positive 15. Square rooting both sides, x is equal to plus minus square root of 15. Now I plug this x value into either of my equations. My simplest equation to use is probably the 3y is equal to 4x plus 4 equation. So 3y equal to 4x plus 4, where I need to actually have y by itself. So I do need to divide 3 by everything. So y is equal to 4x plus 4 over 3. And my x value is going to be plus minus 15, or plus minus square root 15. So y square root 15 is equal to 4 square root 15 plus 4 on 3. And y of negative square root 15 is equal to effectively 4 minus 4/15 over 3. Now I can either use these as equations in my set of coordinates, or I can use the decimal value in my set of coordinates. So I'll show you what both of those options look like. So for x being positive 15, and then x being negative square root 15, our y values were 4 square root 15 plus 4 over 3, and 4 minus 4 square root 15 over 3. So those were my two sets of coordinates. In decimal form, that would be 3.87 and 6.497 for this first one. And for the other one, you would have negative 3.87 as the negative square root 15 and negative 3.831 as the y value. Now, for this particular question, I probably wouldn't put it into decimal form unless it was a tech active question. I would leave it as fractions and surds because that gives you a proper set of coordinates, not a rounded set of coordinates, so not an approximation. And in this topic, you'll need to be able to give both exact answers and approximate answers. So that calculator answer is an approximation, whereas the surds and square roots, these are exact answers. And I think we'll leave it there for this video.